India reached the moon for less money than some Hollywood space films, not because it used worse technology, but because it played a completely different game. And once you see how it actually worked, you won't unsee it. Because the real question is not how India managed to do it so cheaply, but why the result did not look cheap at all. Most space missions follow a simple logic. More money means more power, bigger rockets, faster transfers, and more spectacle. India ignored that model. Instead, it treated the mission as a tightly constrained engineering problem, where every decision had to justify its existence, and that shift alone changes everything. Chandrayaan-3 did not rush to the moon. It followed a longer, carefully calculated trajectory, looping around Earth multiple times and gradually building energy by using gravity instead of burning large amounts of fuel, which is essentially the space version of letting physics do part of the work for free. And that leads to the core principle. In space, speed is expensive, fuel is everything, and gravity, if you understand it well enough, can reduce how much you need of both. So instead of overpowering the problem, India used the environment itself. A useful analogy is a mountain climb. One team takes a helicopter straight to the top, which is fast, expensive, and visually impressive. The other studies the terrain, understands the conditions, and reaches the summit with far less energy and far more control. India chose the second path, and that decision is visible throughout the entire mission, because this was not a case of cutting corners, but of systematically removing unnecessary complexity. After the failed landing attempt of Chandrayaan-2, the response was not to make the next mission bigger or louder, but to make it clearer. What actually matters? A safe landing, a working rover, and reliable core systems. That is it. That is why Chandrayaan-3 feels so refined, because it is not trying to do everything, it is trying to do the most important things extremely well. While Hollywood spends money to make complexity appear effortless, India's space agency, the Indian Space Research Organization, or ISRO, based in Bengaluru, focused on efficiency instead of spectacle. And the cost advantage is often misunderstood, because it is not primarily about lower salaries or cheaper components. The real reason lies in the architecture of the mission. ISRO designed the system for efficiency from the beginning, using a lower energy trajectory, developing key components in-house, relying on local suppliers, and avoiding unnecessary reinvention wherever possible. This is not just cost-saving, it is high-level systems engineering. At the same time, the mission targeted the lunar South Pole, one of the most scientifically valuable regions on the Moon, because it may contain water ice, but also one of the most difficult to operate in due to extreme terrain, long shadows, and challenging lighting conditions. So this was not a simplified mission, but a technically demanding one, executed with a high degree of discipline. And that leads to a concept that is often overlooked: scope discipline. Instead of asking what else can be added, the focus shifts to identifying the smallest set of objectives that must be executed perfectly. Because Chandrayaan-3 was never intended to stand alone. It is part of a broader sequence of capabilities. Landing is only the first step, followed by docking, sample return, and eventually long-term infrastructure in space. Seen from that perspective, the budget becomes much easier to understand, because this was not a one-time achievement, but a carefully planned stepping stone. In 2025, India demonstrated space docking with the SpaceX mission, and while that may sound technical, docking is a critical capability because it allows spacecraft to connect, transfer materials, and operate together as coordinated systems. That is how you build larger and more complex operations in space. Shortly after, Chandrayaan-4 was approved as a sample return technology mission, which signals a clear shift from simply reaching the Moon to actively working with it. And that ultimately resolves the original question. India did not reach the Moon on a Hollywood budget by accident or through a single breakthrough. It did it by redefining what a space program should optimize for: less spectacle, more structure, less brute force, and more accumulated intelligence. Which is why the budget number, while impressive, is not the real story. The real story is that disciplined engineering is turning into long-term strategic advantage. Because in the modern space race, success may not belong to those who spend the most, but to those who learn the fastest, design the cleanest systems, and waste the least. If you enjoyed this deep dive, like and subscribe to Mind Sprints for weekly insights into the logic behind science and technology. And here is the question I want to leave you with. In the next era of space, will leadership belong to the richest nations or to the ones that engineer with the most discipline?